Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to factor quadratic relations by using a technique called decomposition. As part of this lesson, you're going to learn how to factor a quadratic expression that looks like ax squared plus bx plus c if you can't use any of the techniques that we've looked at so far. So if a is not equal to 1, what do we do? And if it's not a special case like a difference of squares or a perfect square trinomial, then we're sort of stuck. What do we do with that quadratic then? And that is exactly what we're going to learn to do today. So actually, let's create a flow chart that outlines our thinking on what to do when we encounter any quadratic that looks like this, any quadratic relation in standard form. How do we choose the best strategy to factor it? Pause the video here and see if you can come up with your own flow chart on how to choose a strategy to do that. Well, for me, the first thing when I notice a trinomial like this is I ask myself, is there a greatest common factor between the three terms? And if there is, then my first step is always to factor that out. And if it's not, well, then I can just disregard that and keep going. But either way, whatever the result I have, if I factored something out, then whatever is remaining, I have to look at whether or not that is a difference of squares. This would be the easiest of all of the factorizations, right? If it is a difference of squares, then this would just be a squared minus b squared very easily factors into a plus b times a minus b. And then I'm done. But if it's not a difference of squares, if my answer here is no, then I'm in a little bit more trouble. I've got to utilize one of my other strategies. So then I ask myself the question, okay, well, does it look like just x squared plus bx plus c? Is there no a value? Or in other words, is the a value equal to 1? If that is true, then I might try to use the sum product rule to factor that. But if it's not, if there actually is a number in front of x squared, then things start to get a little bit more difficult. It's not a difference of squares, excuse me. So I have to ask myself, is it a perfect square trinomial? If it is, then I can very easily factor that into a plus or minus b all squared using that exact factorization. And finally, if all of these three strategies are not successful, if I have to say, no, it's not a difference of squares, no, it doesn't look like x squared plus bx plus c, no, it's not a perfect square trinomial, then what the heck do I do then? Today, we will look at a technique called decomposition. And decomposition is a way to factor a trinomial, like you see the one in front of you, if the a value is not equal to 1, so in this case it's 8, and it's not a perfect square trinomial. 8 and 27 are both not square numbers. So these are the steps involved in decomposition. The first thing you're going to do is multiply a times c. So in this case, 8 times negative 27 is negative 216. And if we, once we have that, the next step is to find the factors of 216 that add up to 6. So I know that because this is a negative number, one of those has to be positive and one has to be negative. If I take negative 1 and 216, if I add these together, does this make 6? Obviously not. So these are not the two numbers I'm going to use. What about negative 216? Well, obviously that plus 1 is negative 215, and that's still not 6. And you might keep going here for quite a while, and this is why decomposition is the least recommended strategy, because it actually takes a long time to list all of the factor pairs. But eventually you would get to a situation where you're like, negative 12 and 18. When I multiply them, I do get negative 216, and when I add them, I do get 6. So this second step of finding all of the factors of AC that add up to B, that's our second step here. And the reason we do this is because now we're going to actually take this B and split it into these two numbers right here. So if I were to collect my like terms, this would negative 12 plus 18 would give me 6. And I've split it up for a very specific reason, because now I'm going to do something called factor by grouping. So I'm going to factor the greatest common factor out of the first two terms and separately out of the last two terms. Pause the video here and see if you can do that one step. Well, hopefully you realized that both of these are divisible by 4x, and 18x and negative 27 are both divisible by 9, by positive 9. And once you do factor these out, notice that we ended up with the exact same expression in each of these brackets. And that right there allows us to take this and say, hey, I can actually factor out 2x minus 3. Right? This is like saying, if we said 2x minus 3 was equal to something like a, this would be like saying 4xa plus 9a. Well, we would just factor a out of there, and we would be left with 4x plus 9 as my expression. And there we go. We have successfully used this technique called decomposition to factor this expression. We've turned it into two binomial factors. Now, you can always use decomposition to factor a trinomial that looks like this if it is factorable, because not every trinomial actually even is factorable. And to use decomposition, here are the steps. First, you multiply a times c. Then you find two factors of that add up to b. And you can name those factors r and s if you want. And we're going to split bx up into rx plus sx, those two numbers. Then you're going to factor by grouping. So you should end up with ax squared plus rx plus sx plus c. And you're going to take the first two, which are here, and the last two here, and you're going to factor those by grouping them. And you should end up with two brackets that have the same expression in them. That is going to be one of your factors, and the coefficients are going to be the other factor. In this example, let's factor 9x squared plus 24x plus 16. And I'm going to just jump straight to decomposition because that's the example I want to show you. So first I'll take a times c and get 144. And now I'm going to look at the factors of 144 that add up to 24. 1 and 144 make 145. 8 times 18 gives me 144, and that's 26, just a little bit off. But 12 and 12 do give me 24. And so I'm going to split this up into 12x and 12x. And now I'm going to factor it by grouping. So what can I factor out of these two? I think I can, both of them are divisible by 3 and by x. And out of these two, both of these are divisible by 4. So I end up with this expression right here. And notice I can take this 3x plus 4 and factor it out entirely. But then hang on, notice what happens when I collect these two over here. I actually ended up with the exact same binomial factor. And so I can rewrite this if I wanted, and you should do this if this is an option for you, as 3x plus 4 squared. Hang on a second. Wouldn't that make this a perfect square trinomial? I think it actually would have. And if I had noticed that at the start, I could have saved myself all of this work. But it's okay, because at least the thing I learned from here is that even if I don't notice something as a perfect square trinomial, I can still use decomposition because that'll work every single time. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.